afternoon, ladies and gentlemen. Welcome to the Philippine launch of COMOSYS. Yes, let's hear it. Oh wow, we have great energy here this afternoon as we welcome a new generation modeling technology that will be the future standard of steel, concrete, and rebar detailing. Hi everyone, my name is Leah Guerrero. I have the pleasure and honor of being your master of ceremonies for this very special event. And before anything else, we'd like to thank each and every one of you. Maraming salamat. Thank you for being here. It is so nice to see everyone come together, yes, on a Friday as we learn what makes this software, COMOSYS, special. And we have a great program in store for all of you. I know a lot of people were asking, where are the drinks at tonight? They are feeling the Friday mood. Of course, it's coming. We're gonna hear great messages. We're gonna see wonderful videos. And don't just take our word for it, okay? Because later on, there will be a live demo of each feature that will give us a better idea of what makes it comfortably similar to your favorite modeling software, and what makes it different in a good way. So I wanted to check, is everyone ready? Good energy. Kailangan nata yung mga drinks. I think we can do way, way better than that. One more time. Are you ready for a great program? Oh, so much better. And because you are pumped up and ready to go, let me introduce this individual, a distinguished gentleman who will give us the opening remarks. He has over 25 years of experience in the structural steel industry. This engineer has been around the block, in and out of the country, in pursuits of livelihood and excellence. His relentless passion for innovation has propelled his small ragtag crew of backyard detailers to become a growing company that not only focuses on structural drawings, but also offers steel solutions. On his free time, he relaxes to the soothing sounds of 70s folk music. I think we're giving away a bit of his age there. And he's a proud father of 2 sons and a daughter. Ladies and gentlemen, it is my honor to introduce the founder and president of Steel Drafting Innovations, George Mamurik.
To those of you who have known me since the late 90s and the early 2000s, which I can fairly point out to be the dawn of the 3D steel detailing modeling and detailing system in the Philippines, you and I will learn that whatever small contributions we've had given to the steel detailing industry before, if there ever was a far cry from what you're about to hear and witness today. So, how do you think was the steel detailing industry during the advent of 3D modeling softwares? Anybody? So, but for us then, during the early 2000s or late 90s, you know that back then, we just had to make do with educational versions, right? Or the super legit copies of this software from Captain Jack Sparrow from the Caribbean, if you know what I mean. And then, just like a humble binatog seller or with a very cheap professional fee that he was worked for, Captain Jack Sparrow offered his services to those companies on how to use this relatively lesser-known detailing software for free, gratis. Just thank you for him was enough. Because he said that his intent to make to make a positive impact to the steel detailing trade was profound. Yeah, right. But then with a bit of luck and a touch of miracle, this spark that Captain Jack Sparrow started slowly and steadily made a positive impact. And admit it or not, it was that catalyst that we needed to change the steel industry in the Philippines back then. Now, the newly learned knowledge on how to operate 3D modeling and detailing software elevated the trade and the value of Filipino steel detailers. I can get to have that claim. So, and best of all, many of those companies that Captain Jack Sparrow has trained, if not all of them, are now the biggest players of the steel detailing industry in the Philippines. And directly or indirectly, they are still benefiting from the trainings that Captain Jack Sparrow has done before. And that is why you are all here today, because I wanted to share a similar sense of excitement as we introduce to you COMOSYS. And just as those experiences we had before with Captain Jack Sparrow was transformative and career-changing, COMOSYS has the potential to redefine the steel detailing and engineering industry. So here, Here's to embracing changes which don't need to be complicated or expensive. Here's to us remaining open to anything that will push the boundaries of the steel detailing industry and everything that is related to it. Take it from me, with all humility, I, Captain Jack Sparrow, now signing off, as I am now at the helm of this ship called Steel Drafting Innovations, your official COMOSYS distributor. Thank you and welcome to the launching of COMOSYS.
Please allow me to introduce our special guest. And if you have questions for him, please do note that in your heads. We will open the floor later on for Q&A. For now, let's get to know him a bit better. He has over 30 years of experience as a structural engineer. His work has revolved around large-scale industrial plants, seismic design, interdisciplinary coordination, finite element analysis, and project management. He writes poetry as well, is deeply interested in the origin of languages and etymology, and speaks 5 languages. Maybe we'll make it 6 with Filipino. Over the last 15 years, he has been involved in studying the history of economic thought and the current global financial system, along with its inherent problems. His current interests include blockchain technology, underlying causes of chronic diseases, and obviously, COMOSYS. So, apart from being a capable speaker tonight, he would make for an excellent, brilliant dinner guest and conversationalist. He is 57 years old and a father to 2 girls, all the way from Turkey. Let's welcome the CEO of Proya Software and Trade Incorporated, Syed Atik Ahmad.
So, the doors are locked, and you cannot leave without buying at least 1 license. Now, I've been introduced, so I won't bother introducing myself. I'll just repeat my name. My name is Atik. You can call me Atik. I'll be dividing this presentation into 2 parts. What I'll do is I'll give a quick outline of the company, its history, what we've done and where we're heading, and sort of an executive summary, if you will. I'll try to keep it between 15-20 minutes. Dinner is always more attractive than anything else. And then I'll go on to the live demo. And in the live demo, what I'll focus on, because I've done these live demos so many times, if I try to go into detail, we'll be here till breakfast without having dinner. So we won't do that. What I'll focus on is what is different about COMOSYS as compared to the regular softwares out there. And that'll So it's nice to see so many of you giving up your time and being here, and this is the way capitalism works. This is the way we all earn our living. And it reminds me of a joke that an employee giving up your time and being here, and this is the way capitalism works. This is the way we all earn our living. And it reminds me of a joke that an employee comes up to his boss and says, "Oh, that's an amazing car you have, boss." And the boss says, he looks at him and he says, "You know what? If you really work hard, then next year I'll get a better one." So that's the world we live in. But let's move on to, okay, can we connect my, yeah, okay, that's fine. You can see on the screen. So this will be the PowerPoint part where we'll be talking about the executive summary. So a brief introduction to the group of companies. You can see a few names out there: Procon, Econ, Proya, Proen, Econut. These are all different companies, but they all belong to the same group of companies. Proya being in the center, being the software development company, which I represent. The others are design and detailing companies, general contracting companies, so basically the whole construction industry. So a little bit of the history. Proya was established in 2001. Finite element module was completed. That was the initial plan. What we wanted to do was to basically just do a finite element module and then link that up with Tekla. Create a connection between our finite element module with Tekla. That was the initial plan. Obviously, that went horribly wrong. In 2007, we developed the steel detailing and shop drawing module by 2007. And I would like to share with you that since 2008, we have stopped using Tekla in-house because obviously it's our software. We have to use it. We can't develop a software and not use it. But also because the productivity is more. We have learned over the years that we can actually produce more resources or produce more with the same resources, whichever way you want to use that. In 2012, we developed by 2012, I should say, we developed our concrete and rebar modeling module, which is a very capable one, by the way. And in 2013, the software was launched for sale inside Turkey, right? And in 2017, we started looking for international exposure, and we went for the global push. That's a brief history of the company. What we do, obviously, besides the software development, which is obviously what the core of what we do, but we also give project-specific support. So, for example, if you have a very large project in which you want our support in developing specialized macros, for example, or something unique to that project, which will really boost your productivity, we give help in those things. We provide training. We provide custom-built solutions for the modeling side, like I said. The global reach of our software is in its childhood, in its infancy, but it's growing steadily, and we're getting pockets of penetration everywhere. The response is very, very good. The response is very positive, and we'll talk about the reasons in a minute. So the purpose of this presentation is to be obviously physically here with you. Nothing can, no Zoom meeting can be like this, right? So online webinars just not the same. To give a strong message of solidarity, we realize what the prices of software is doing to the business globally. There's hardly any profit for detailing companies. So we're basically working for the software production, producing houses. I mean, we realize the problem over here. We want as good solutions, if not better, at cheaper prices. So to give an executive summary, obviously, of the software, and followed by a live demo. So what is, in a nutshell, you have obviously heard about programs like SAP 2000, STAD, Global, ETABS. This is one group. This is design and analysis softwares. Then you've also heard about programs like AutoCAD, BricsCAD. These are like general purpose drafting, you can call it. But then you've also heard about modeling programs, 3D, supposedly 3D modeling programs like Tekla, like Revit, like Advanced Steel, like BoCAD, like Aviva. They're all separate groups of programs. And what we want to do is we want to bring them together. So what we want to do is we want to start with the green field with nothing, and we start with conceptual design, analysis, then we do the structural analysis, and then we do the design, the structural design, then we do the modeling, then we do the production of drawings, and then we follow it up hopefully with some post-construction stuff as well. So finite element analysis is at the heart of the program. Modeling and detailing is also at the heart of the program, as is shop drawing production and fabrication drawings. All three have been put together, which is a unique combination. Normally, it's very difficult to get this combination right. Many programs have attempted it, but eventually they've ended up separating the two. And the reason is, there are many reasons, but we feel that we have a good mix, a useful mix. And the reason why I'm saying this is not because it's our software, it's because we also use it. We're not just software sellers, salesmen, we're actually users of the program. So a few slides. You're familiar with this kind of a picture. This kind of picture will remind you of programs like SAP 2000, right? This kind of a picture will remind you of deformed shapes, dynamic analysis, internal forces. This kind of a picture will remind you of shell analysis, complicated shells with internal moments and shears and axial forces and stuff like that. So that's familiar to one part of the group. But then there is this. This is a different sector. This is 3D steel detailing, 3D modeling, all the way down to the nuts and the bolts and the cuts and everything there is to it. So this is a whole separate thing. But in COMOSYS, you will get this all in one package. You won't be moving from one software to another software to another software to another software. It'll be, if you can do it, it'll be there. If you can't do it, if some feature is missing, obviously we slowly develop more and more features. But the idea is that it's all put together under one umbrella. You won't be using, and I'll talk about that in a second as well. Once you do your analysis, you will be using the same model for modeling, for 3D modeling. You won't be required to recreate the 3D model. So more pictures. This will show you some general purpose plate work. And then it's concrete as well. Not just limited to steel, it's concrete as well. And not just concrete, but rebar as well. So just going through the pictures to give you an idea of what kind of a software we're looking at here. A few glimpses. I don't want to waste too much time right now, and hopefully get to better parts of the presentation. So that's a glimpse into a drawing produced directly from within COMOSYS. You don't need to go to AutoCAD for this. You don't need to go to some other program for this. All under one umbrella. Once you start off, analysis, design, detailing, production of shop drawings, same environment, same program. This is another picture, more familiar to you perhaps because our audience today is more to do with steel than concrete. But this is a steel assembly drawing you're seeing on the screen. I prefer to leave things untouched. I don't try to tweak the drawings so that they look good. All automatic drawings can always be made to look better and better by hand modification, tweaking, cleanup, which you know much better than me. In fact, I was talking to George and he was explaining to me how maybe perhaps more than 50% of the time is spent on drawing cleanup and maybe 50% on actual modeling. So to be able to get good, clean drawings without or with a minimal need of cleanup is extremely important. It's extremely time saving. So the major core features, it's model based, it's specification driven. It's model based, you know what that means. It's specification driven means that everything or most things have a specification behind the command. You can change that, you can modify that, and the macros will work according to that specification. The commands will work according to that specification. So once you set up the specifications, you will then have your company. It's like setting up your company and your company styles. And once you've got that, it'll be a smooth ride. It's a 64-bit architecture which supports very large models. I'll be showing you a few. So this is one of the questions which comes up very regularly that, okay, you can do a portal frame, you can do this, but can you really do a very large model? Is it really possible to handle extremely large models in COMOSYS? So I'll be showing you some of that. Unrestricted shape modeling, we're not restricted to steel frames or anything. You can actually model an aeroplane if you want to. Theoretically, the modeling is pretty general purpose. It's got multi-user support, which means for larger projects, you can have more than one person working on the same model at the same time. It's got lots of interoperability. So IFC is the standard, as you know, but we also have, knowing that Tekla is the market leader as we speak, we have also developed something which is like a two-way bi-directional from COMOSYS to Tekla and the other way around, in which you don't get just dead objects, but you get native objects on both sides. Export to SAP 2000, Aviva, STNF, AutoCAD, CNC, the list is long, and it's fully customizable. You can customize the macros, you can customize the defaults of drawings and stuff like that, save them away, like I said. And it's also fully programmable, which means that if you have programmers in your team, and these don't need to be like very high-end programmers, they can be like .NET-based, C#-based programmers, you can develop your own components. You can develop your own entire softwares if you want, built on top of COMOSYS. So if you are working for example, the HVAC industry, and you want to develop an HVAC module, you can do that. So that's one thing which needs to be mentioned. Now, frequently asked questions, can I do everything I do in other softwares in COMOSYS as well? The answer is yes. More often than not, I don't want to say always yes. It's never always yes, but 98% of the times, it's yes. So rest assured about that. Is it faster than other softwares in modeling? And this one, I can assure you that once you get your people trained, which I always say is a process of about 2 months, especially for Tekla users, already Tekla users, they can adapt very, very quickly. Then they will get close to their Tekla modeling speeds in 2 months or 2.5 months. In 6 to 12 months, they will hopefully have reached the best speeds, which means in my personal experience, and like I said, we collect statistics on these things a lot. In my personal experience, that would mean at least double the speed of your existing possibilities. How long will it take my team to learn? I'd already tried to answer that. What is the price? Well, we'll probably find out towards the end. Is it lesser? Yes, it's lesser, for sure. Substantially lesser. How will I get training for the software? You can come to us. You can come to our representatives here in the Philippines. They will help you out with face-to-face training, online training, video-based training, whatever it is that you want will be provided for you. Successful projects, this is an incomplete list. This is just a list I want to quickly go through. These are all actual projects done. These are actual pictures. These are not just fake. These are power plants done. Every building you see on the screen was modeled and detailed by COMOSYS. Every single building. I'm not talking about this building over here or this building over there. All these buildings were modeled in COMOSYS. Every single one of the building you see on the screen was modeled by COMOSYS, detailed by COMOSYS. Once again, every single building you see on the screen, food and beverages facilities, was modeled completely by COMOSYS. miscellaneous industrial plants, defense industry, aviation projects, aerospace industry, and last but not least, we're so confident that we even built our own headquarters and even analyzed it, so we're kind of confident that it won't collapse one day. So the Pro headquarters today was also designed entirely by COMOSYS. Our representatives in the Philippines, you already know them. You already know them much better than we maybe because they've been here for so long. Steel Drafting Innovations and Solutions. You know their addresses, emails. In case you don't, you can take a snapshot if you want. You can contact us directly as well. And that's basically the end of the boring part. Because I say the boring part because people tend to get restless when I'm doing stuff in PowerPoint because they want to see the actual program, right? Because I can say anything on PowerPoint, right? So people are actually getting angry. They're smiling, but they're getting angry. Come on, get to the real part. Which reminds me that one of my friends, he made me angry once. And he said, you know what, you should be more connected with your feminine side. So I crashed his car. And didn't speak to him for 1 month. So now he's okay. Anyway, let's get to the live demo. Let's see, okay. So I'll just go through, we don't have much time. I'll plan to finish everything in 1 hour. So I'll do quick snapshots of a few things over here. I'll talk about a few key features here and there. There's so much, like I said, to talk about. We can go on for 12 hours and it won't be complete. So there's something which we like to talk about, and analysis companies will know that well. That's what we call super shells. It's something interesting. Super shells are shells, but super shells, right? So you know what shells are, shell analysis. You know, so this is a shell, this is a shell, this is a shell. But actually this is not a shell, this is a super shell. This is a shell which will get meshed automatically. So this is, think of it like a column and a base plate over there, which you've modeled like that with some stiffeners and everything. But when you say, let me go to the analysis. When you say mesh automatically, you see immediately it meshes it. And it meshes it with knowing the connectivity. Can you see the mesh that this plate is aware of this plate, and this plate is aware of this plate, and this plate is aware of that column flange, right? So just by a press of a button, you can create these automatic meshes, and that's obviously you can load them as well. And but if you see on the screen the mesh parameters, let me remove the mesh. Right now, the mesh is an average size of 50 millimeters. What if I were to say that, okay, for this stiffener, I want a denser mesh. If I were to just click on this and say I want a 10 millimeter mesh for this, and 50 for everything else. So a 10 millimeter mesh for this plate, but now how will it connect with the neighbors? It needs to connect wherever there is contact, right? So if I just say that and say, can you please mesh it again? Just look at what happened. The 10 hit the wall and it turned the wall into 10 as well. But then slowly as you move away from that contact point, it comes back to 10, back to 50, right? So automatically you see that it's adaptive. I can make a hole over here and the mesh will auto-generate. I can add additional plates. I can make it a very complicated one. So let me show you a more complicated one. This is like a steel silo bunker with many more plates than the other one, as you can see on the screen. And it is unmeshed. And these plates are big super shells. And they know exactly, they automatically sense their neighbors. They automatically know that I have something touching me, right? So if I were to say, go ahead and analysis and say, go ahead and mesh that, you see how quickly it varies the size of the mesh, and as it touches another plate, there is perfect contact. You can see over there, the exact compatibility of the nodes. And people who are into analysis and design will appreciate that more. But this is extremely useful if you're an analysis and design company. Like I said, there are hundreds of features. I'll just be skipping over most of them. This is something which is interesting. The loading is very interesting, but we won't have time to talk about that. Let's see. Let's move on. Let me move on to something you will like. It's about detailing now. So we have a feature which is not available in any other software. And this feature we call IntelliConnect. And the reason why I say it's not available in any other software is because we do have something which sounds similar, which is AutoConnect or rule-based joints in other softwares as well. And what do I mean by rule-based joints? By rule-based joints, I mean that you define the rules and the program automatically selects from the library whenever it finds that situation and connects for you, right? That's what a rule-based joint is. That's what AutoConnect does. But the thing about AutoConnect is that it's a one-by-one connection. So one element is connected to another element. One element is connected to another element. For each one, you define a rule. So for example, you will define a rule saying that when a beam comes from the flange side of the column, use this connection, right? And then when a beam comes from the web side of the column, use this connection, right? When a brace comes from the side of the column, use this connection. But what happens in real life? What happens in real life is something like this. So for example, here we have a complicated situation in which there's a column. There's a beam coming from the flange side. This is a fixed connection. There's a beam coming from the web side. This is a simple connection. And there's also a brace coming into that same point. Now we might set up our rules saying that whenever you see a beam like that, use the haunch connection. Whenever you see a beam like that, use the stiffen end plate connection. Or whenever you use a brace coming in, use the bolted gusset connection. But what happens in real life when we do that? I'll show you exactly what happens. So what happens is the program will come in and it will connect the haunch, right? That's the first rule. Then the program will come in and go to your beam-to-beam connections, beam-to-column connections, and say, okay, this one and this one, right-click. And then it will come to your bolted gusset connection and say, okay, this one, and right-click. And this is what you get in real life using AutoConnect. Something you just can't use because all three connections were unaware of each other, right? The haunch was unaware of the stiffen end plate connection. The stiffen end plate connection was unaware of the haunch. Both were unaware of the bracing. They were just connecting. So can you use this as it is? No. You need to either delete it or you need to go inside each of the macros and spend some time over there. This is what we attempted with IntelliConnect, that if we could find a way to make the program aware of everything which is happening at that point, everything which can possibly happen at that point, if we can find a way to do that, and if the macros can talk to each other, and if they can find solutions in which they can squeeze themselves in without clashing, or if they can move around a bit, maybe, you know, those are the kinds of things I'm talking about. If we can do that, then maybe not AutoConnect, but maybe IntelliConnect can help us find a solution for this. Do you get it? Do you get the problem? It's a very complicated problem. It's almost like artificial intelligence because it can get very, very complicated. But we're developing it. We have been developing it for a while, and I'll show you some of the things. So in summary, what is IntelliConnect? It attempts to find a solution for a whole zone, you can say. And the zone, let me undo what I just did. Yeah. So it attempts to, for example, if there's a beam over here, secondary beam, and there's horizontal bracing, it will attempt to find a solution to connect them all together without any clashes. if need be, it can even shift the members, right? So I'll talk about that. But it also does simple things. So for example, if I were to just move away, by the way, what is that technology which helps us find the zone? What I just said, this area. How can we define that we talk when I say over here, which elements are involved? For that, we have this special feature called the finite element node, which has all the connectivity information at that point. So this little blue node you see on the screen, I hope you can see it, this one. This little blue node, if I double click it, you see something called, it says the connectivity of 4. It knows there are 4 elements coming in there. One is the continuous beam, one is the secondary beam, and there's a bracing and there's a bracing. So it knows the connectivity. And because it knows the connectivity, it also knows what those profiles are. It also knows how big a connection will be created when they're done. So theoretically, it has the information. And the challenge is then to use this information to find a viable solution. Okay? So how does it work? It works basically by selecting a node and calling IntelliConnect. That's how it works. You select a node and you say, hey, IntelliConnect, can you do something about this? Given my rules. I have a set of rules in the background, but given those rules, so let me do the simple cases for you first. I'm going to select the whole building, okay? And I've also selected the nodes, obviously those little blue nodes which you just saw. I've selected everything basically. I don't need to just select the nodes. I can select everything. And I can say right click. I can go to my IntelliConnect menu and I say create the GERT connections. Now just imagine what I'm saying over here. I'm saying go through this entire model, find the GERTs. Find the GERTs. If they're one-sided, find them. If they're two-sided from both sides of the column, you know what I'm talking about. The column can have 2 GERTs coming in, or they can have a single GERT. Find them all, wherever they are situated. And okay, let me just go through this. I say click create GERT connections. And it says, okay, I can give you these 4 options. What kind of a GERT connection do you want? Okay, I go with the bracket type without cut. I happen to like it. You can like something else. And we'll talk more about adding more options to this. So let's just say bracket type. This is the GERT connection which I want. Don't forget, I've selected the entire building, right? And I'm saying just create the GERT connections. And I'm going to press run over here. Now it's looking through the nodes. It's finding the connectivities. It's finding the beam groups. And it's trying to classify where the GERTs are. And it goes, whenever you see done over here, it means it was able to connect. If it's unable to connect, it'll say could not be connected, right? And then you can go there and do it yourself manually. But what has it done? Let me close this and let me zoom in. So it has connected this GERT. It's found the GERT and connected it. What about the double-sided ones? It's found the double-sided ones and connected them as a double-sided connection. Not as two separate connections. Not one connection for this and one connection for the other one. It's a common connection. It has found, like I said, the ones at the edges. It's found them all. It's found all the GERTs just by selecting the nodes. It's found all the GERTs. It's classified them into one-sided connections, two-sided connections, and gone ahead and done the detailing. What about if I selected the whole thing again and said, right-click, sorry, and I said IntelliConnect and said create Perlin connections. It gives me certain options. Do you want the angle type, for example? Do you want the folded plate type, this type? Let's go with the angle type, for example. And I want to reverse the cleat. So the cleat is on the other side, right? And I just say, okay, please find all the, I've selected the entire building. Just go and find all the connections where purlins are doable. And it gives me a report at the end. I can just close that. And my purlins are connected, right? Just imagine what I'm doing over here. These are the easier cases. I'll get to the harder cases in a minute, okay? But imagine the power which it can bring to you. Let me select everything, right-click, IntelliConnect, and say, create the splice connections. Now, splice connections have to be between elements which are parallel to each other. Like this is not a splice connection, right? This is a splice connection. Now, when I do that, it goes inside and it finds 6 places where there were splices in the model. And very conveniently, it goes through the entire model. Now, it looks a bit like magic, but it's actually not magic, obviously, but there's a lot of programming involved in this. There's a lot of intelligence involved in this. What about these sag rods? These sag rods and there need to be little holes over here for the sag rod to go through, right? Over here, over here, over here. All these need to be connected. What if I just went like that and right-clicked and I said IntelliConnect, create my sag rod connections? It'll find the sag rods. It'll find the girts which are connected to them. It won't make a mistake in finding the wrong element. Let me just go ahead. Okay, so it's mostly done. And if I zoom in now, can you see the little holes? Yeah? These weren't there a moment ago. But what it did was, it just went through the entire structure, found the sag rods, found the girts, found the connection points, and did my connection. Now, up till now, these are comparatively a lot easier. I'll talk about 2 more cases, which are much more difficult to solve. And those cases I'll call, those are the difficult cases. There are many more cases actually, but I don't want to spend too much time on this, just to get you an idea. These are the floor beams and the beam column, the one I did in the beginning, the column, the beam, this beam, and this, this horrible mess which we saw over there. I'll do examples of both. So coming to the floor beams, if I have a situation in which, so I'll do it manually for you. Let's say I want to use the fin plate connection over here, and then I want to use the corner bolted gusset connection. So this one and this one with this one, and then this and this and this. So I've made a nice connection over there with the beam connected with the fin plate, and the horizontal braces connected with the corner bolted gusset connection. Right? This is a very common way of connecting, especially when you have not too big loads, etc. But what if my let me undo this. What if my requirement was to use the stiffened end plate connection? Okay. Now it's impossible to make a connection over there for the bracing, because it's already clashing, as you can see. Now, in actual practice, what do? We shift the horizontal braces a bit to the left or a bit to the right, right? That's what we do. 5 centimeters up to 10 centimeters sometimes, depending on the situation. Now, that's a complicated decision. That's a very complicated decision, which needs to be taken. Let me undo that. So what I'll do is, let me go to my IntelliConnect menu and press Shift, open up some of the settings, and go to my beam-to-beam bracing connections. Let me first beam-to-beam bracing. Okay, that's fine. I don't want to use the fin plate. I want to use the stiffened end plate connection, the one I just used, the stiffened end plate connection. And for the other one, I want to use the bolted gusset connection or the corner, whichever one works. But I know that they're not going to work. They cannot work unless I shift my bracing. I know that from experience, right? So these are my parameters. But what I will do now is, I will select, now please focus on the screen. I will select this node. If you remember, I said everything works by selecting the node. And the node knows the connectivity, and then it knows what to do from there. So with my settings that I want a stiffened end plate connection, and I want a bolted gusset connection, can it find a solution? So please look at the screen, and you will see hopefully something nice happening. Did you see that? Is that interesting? Well, actually, it's very interesting because these are the time-consuming things. These are the things which take hours and hours, especially for young detailers, especially for detailers who are not very experienced in steel detailing. They will look at this for hours and think about what do I do now, right? So having the ability to find this kind of intelligent solution for places like this is extremely time saving. Now I did this for one joint. What I could have done is, obviously it's going to take some time, so I'm not going to do it right now. But what I could have done is I could have selected the entire floor and said, make me only the beam to beam connections with the bracing using these parameters, right? And maybe it's going to take 1 minute or maybe 2 minutes, but the alternative is maybe half a day, right? So when it works, it doesn't always work. IntelliConnect doesn't always, it's not magic, but it works in a lot of very commonly occurring situations, a lot of very commonly occurring situations. And when it works, it's going to be the difference between 2 minutes and half a day. And that's a huge difference. That's the difference between doing something in 2 months and 2 days, something like that, when it works. When it doesn't work, I've got something else to show you as well later on. What about situations like this? A beam, a column, another beam coming from the flange side, a vertical brace, the one I did in the beginning, the mess I created, right? So let me press Alt-D and see. Yeah, this is the one, the node with the connectivity of 4. I've selected it. Let me go back to my IntelliConnect settings and go back over there. Let me remove this, and I'm going to connect my beam to column bracing connections. Yeah, beam column. This is the category. Obviously, this requires some explanation. I'm just going to go through it quickly at this point. Beam to column bracing. And let me go to the settings over there and say that I want my haunch for the flange side of the column. I want to use the haunch connection. I've got other options as well. For the web side, I want to use the stiffen end plate connection. Exactly what I did. And for the brace, I wanted to use the gusset plate macros. I'll select that. Okay. And now look at the screen again. Look at this point over here. It's going to make 1, 2, 3 connections. But these 3 connections need to be aware of each other. Okay. So I'm going to just go and press IntelliConnect. So I asked it to use that node, use that information, and find a solution. What it did was, it created the haunch connection, but it knows that the haunch has created these stiffeners over here. And these stiffeners are going to be a problem from the other side for the beam connection, right? So it used the existing stiffeners of the haunch and converted them into these kinds of stiffeners. We pushed out, right? And it made a very nice connection for the beam to column from the web side. And then it used the same stiffener as a corner element for the vertical bracing. Can you see that? Right? So this is what, in summary, what IntelliConnect does. You give it a node, it finds the connectivity, it searches for the options, right? And then it tries to find a solution. And most of the time, you will like that solution, because these macros at the moment, for example, you might say that, okay, why has it put just 1 bolt? Okay, it could be a question in your mind. And the answer is, the moment you set up according to your company standards, that with this beam you need this connection, with this beam you need this presets. The moment you do that, IntelliConnect starts following your company presets. Okay, so your company presets are set. The node has the information. You just ask it to go and make the connection. Correct? I'll stop here because I have a lot more to say. So I'm here for another 5 hours. Sorry. Now, IntelliConnect is very powerful, but IntelliConnect is also limited. And why is it limited? Because it offers you certain options, right? If you remember what I did was, I just selected something like this, and I right-clicked, and I said, IntelliConnect, Perlin connections, and it gave me these 5 options. What if you don't want these 5 options? What if you want a 6th option, a 7th option, a 21st option? What if you want to do something stupid? What if you really want to enjoy yourself that day, right? So IntelliConnect, while being extremely powerful, is also kind of shackling in a way that it limits you in a box. It says, okay, these are the options I can help you with. If you want to stay within those options, amazing tool. It can reduce a day's work into 4 minutes, 5 minutes. If not, then you just can't use it. There's no halfway. Well, there is a halfway, but it's not really that much fun. But there's another tool which we have developed, which is extremely powerful and slightly slower than IntelliConnect. Slightly slower, but much more general. So you don't reduce a day's work to 4 minutes. You maybe reduce a day's work to 1 hour. But no limitation on what you can do. No 6 macros to choose from, 3 macros to choose from. Do what the idea over there is. Remember, I selected a node and then I said connect. In that case, the name, by the way, is IntelliClone. IntelliClone is the technology I'm going to be talking about, right? And the idea is that you provide the solution for one node, but exactly the solution you want in your project. Whatever it is. Modeling is unlimited, as you've already seen. You can do anything you want. You can create cuts and bolts and welds and, just play around. Do whatever you want with that node. And when you are done with that, COMOSYS will then find similar nodes everywhere and apply your solution to those nodes. Okay? And I'll try to show that, and I'm sure you will like it. So imagine this. Let me zoom in there. Now, just bear with me. Let's say I want to do this. Let's say I want to create the fin plate connection over here, right? And then I want to create the corner bolted. This is what I just did a while ago. Okay, this is what I want to do. This is my solution. This is my solution. It can, like I said, right now it's based on macros. Right now, IntelliConnect can also do this. But imagine if this was something IntelliConnect couldn't do. Right? Just imagine that case in which this is outside the scope of IntelliConnect. It's something general. Okay. Now I've used 3 macros over there. Now just watch me. Select any, if the macros are not exploded, you can explode the macros as well, by the way. With IntelliClone, there is no limitation. You can explode the macros, you can move stuff around, you can add more cuts, you can add more extra welds, you can make a new chamfer, you can do all that. But we'll do that slowly maybe. But all I need to do is, if the macros are not exploded, I'll select just one element from every macro. So I've selected 3 plates, one from each macro. One from the fin plate, one from the bracing, and the other one from the bracing. And also, I select the node. Always remember, the node is the key. The node is what knows what's happening around this area. Okay? So what did I do? I select the node. I always select the node. That's for sure. And after the node, I select one element, any element. Could have been the bolt, the weld, the plate, anything. A cut even. One element from each macro I've used over there. Okay? And now watch the screen. I go to my IntelliClone menu and I say clone all. Okay? I'm going through a lot of steps quite fast, but when I do clone all, it does something. It does something which is called joint numbering. And this is a unique feature of COMOSYS. Joint numbering goes through the entire building, finds all the nodes, and then numbers them. Like we have numbering, like this beam is the same as that beam, and that kind of numbering. But this is joint numbering. This is different. This means this joint is the same as, potentially the same as that joint. Okay? So in this joint, the main member is IPE 300, the secondary is IPE 140, and you've got two bracings of angles 60 by 6, right? It's looking for the building for this exact combination, coming from the exact angles. So even if the angles are different somewhere, it's not going to group them together. The situation needs to be the same. Okay? Now, what did it say? It says there are 19 unconnected joints. So it went through the entire building and it said, okay, I found 19 others like yours. Okay? It's found 19 other joints. So I press this button, show the unconnected ones. I've connected one. I'm asking the program to show me the unconnected ones. Now when I do that, just see what happens. I'm going to pull this aside. It's going to filter the building into only those areas which are similar to my source. Can you see that? Only where the main profile is the same, the secondary profile is the same, the braces are the same, and the angles of the braces are the same, or at least within certain limits. Okay, so maybe there's a plus minus 5-degree difference. You can tell the program that include those as well. Okay, now once it shows me, all I need to do is say proceed, because I'm happy with this selection. If I say proceed, just see what happens on the screen. That's it. Everywhere in the building, my solution has been applied. Right? Now, I want you to imagine how useful this can be, because now you're not limited to certain macros. Now you're not limited to certain templates, if you will. Basically, you decide what you know, and I'm going to do a few more examples of that, right? So just see how quickly I've gone through these 19 connections by making one connection. So this has reduced my work 19 times maybe, right? Let me right click and say show all, and the entire building is visible. Now let me do something else. Let me go down here, go zoom in there. There's a beam coming in, there's a channel coming in like that into a main beam, and my client says I want to connect this with the stiffen end plate connection, right? This is what I want to do. A stiffen end plate connection. Can you see it? Right? It's coming in at 45 degrees angle. Okay. What do I need to do? You tell me. I need to select any element created by the macro and select the node. Right? Then move out and go to my clone all. That's all I need to do. And what it is, it says there are 11 more cases in the model. Can you show them to me? And it shows them to me. These are where it has found the exact same thing in the model. However complicated the model could have been, it'll find those for you. Okay, I'm okay with that. I'll just say proceed. And that's it. My connections have been made. Now, I'll show you the ones which are not made. So what about the other side? This one is connected over here. Why is this one not connected? Because there's two elements connecting over there. It's not the same situation, right? Why is this one not connected? Because it's got one coming in from this side and one coming in from the other side, and two braces as well, or one brace. So let me do this. Let me do something like this. Let me select like that, say show only, do that, and make my stiffen end plate connection. Then let me make my fin plate connection. And then let me go in and make my corner bolted gusset connection. Okay, so I've made a complete solution over here. Okay, I've connected this one with the stiffen end plate. I've connected the other one with the fin plate, and this one with that. Now, what do? I select one element from each macro. Okay, so I'm going to select this one and this one and this one, and I'll never forget to select the node. Okay, let me show the whole building. Go to my wonderful command over here. Say clone all, and it says there are 3 more cases like this in the model somewhere. So I wanted to show them. So you can see it's found the cases which are similar, exact same orientations. And now all I need to say is proceed with the cloning, and the cloning is complete. Now imagine going through your structure like this, right? You start in the morning, and one by one, it's going to flag those nodes. And in one go, you will actually connect 20 nodes and then 20 nodes. So instead of moving one node at a time, you're jumping 20 nodes at a time. So if your entire building, so for example, this one, let me show all. Let me see how many nodes we have in this building. So we have 501 nodes in this building. Normally you would connect things 501 times. You would go connect, go to the next one, connect, go to the next one, connect. With IntelliClone, you will divide 501 by roughly 20, so maybe something like 25, and you will go through 25 steps rather than going through 501 steps, right? I just want you to imagine the power that can give your detailing team. Now, let me show you something even more interesting. Now, let's say over here we have a problem, and the client wants us to use the stiffen end plate connection. And you know, whenever we use the stiffen end plate connection, we have a huge problem with the braces because they just don't connect. So I go to my, I know I need to shift. Now with IntelliConnect, the shifting was not in your hands completely. It was to a certain extent. You can have the parameters like move by 1 centimeter at a time, and then never cross 10 centimeters or whatever. You have certain controls, but over here you have full control. So let me do something. Let me select this and adjust the frame manually. Go from here, and let me see. This is the Y direction. So let me say DY, say 110 millimeters. I want the exact amount I want it to be shifted. Okay. Now, this is under my control now, not in the control of IntelliConnect. I decide as the detailer what I want to do. And then I go to my, instead of the corner bolted connection, I go to my bolted connection. And I create a connection like that. I don't like it. It's still clashing. So I go inside. And I make some changes. The first change I make is I don't like this, the left stiffener. So I remove the pink stiffener on the right. And the second thing I do is I reduce this one to 50 millimeters. So I've limited the gusset plate, right? It was longer. Is it clashing? It's still clashing, so I don't like it. It's almost clashing. Maybe I can increase it to 65 or something. Yeah. Oh, sorry. I need to reduce it actually. I need to reduce it to something like 35, right? So, okay, now this works for me, right? I've shifted to my liking. I've made modifications inside the macro. Now, note one thing. Okay, let's go through it. What do? I select this one, and I select the node. We've learned that, right? Now, I'll show you something. Let me go to my IntelliClone menu, say clone all, and it says there are 19 more occurrences, right? So I show the unconnecteds. Now, this is interesting. This one has been shifted by me. You just saw me shifting it. But these ones are not shifted. These ones are still where they were, right? So I have created a shifted solution at the source. It still found the targets because those are potential targets. They're not, right now, they're not exactly the same as the source because the source has been shifted. But it knows that although it has been shifted, I can still do something at the target to make it look like the source. Okay? And that's very important. So in the previous examples, the source and the targets were exactly the same. In this example, the source and the target are different and yet the same, right? So there are 19 occurrences of that particular combo I've created. And I'm going to say proceed. Now, when I do that, just look what happens. They've all been shifted. This one has been shifted. This one has been shifted. This, if you appreciate it, can dramatically reduce your time. If you know how to use it, if you know how to make the best use of it, in the best cases, you will reduce your time by 20, 30 times if sometimes. In the worst cases, a couple of times, right? But it's very beautiful because you can go through your, and I'm not showing you some of the very nice stuff as well, in which you might be thinking, okay, now I've created some things. How do I know where to go now? You might be asking this question. Okay, as I finish the project, less and less remains unconnected, and it's more harder and harder to find the unconnected ones because most of it has been connected, right? So there is a way. It actually takes you directly to the unconnected ones. It will list all the macros, all the joints for you. It'll show you which ones you finished, and then it'll show you the ones which are still remaining, and then you can go to the next one. So you go to the next one, find a solution manually. That's the whole idea of IntelliClone. You find the solution. IntelliConnect finds the solution. You either like it or you don't like it. You play around with the parameters. Maybe you like it, that's fine. And like I said, in many commonly occurring cases, you do like it in many cases. But let's say you don't like it, or the client wants something very specific. What do? You go to IntelliClone. You do exactly what the client wants in one place. And then you say, clone this. Find all the places where this occurs. And that's a real. Now, I'm going to do one final example because that's even more interesting. So let's do a stiffen end plate over here. So I've created a plate like that, a stiffen end plate connection. But the client wants something strange. The client wants that whenever you make a stiffen end plate connection, please also make a little cut on the secondary beam. For whatever reason. I'm not going to go into the why the client wants that. But the client wants that. Whenever it says you make a stiffen end plate connection, you also create a hole, for example, in the web of the secondary. Right? That's what the client wants. But you cannot create that hole with the stiffen end plate macro. But you can model it yourself. So let me see what I can do over here. If I go to my parametric objects, let me go to my parametric cuts and let me do a box cut over here. I'm not very familiar with these things, but let me just roughly place it somewhere over there. By the way, some of these cuts are parametric. You can actually modify them parametrically after you've created them. So let me select that and move that in the X direction, say 50. Let's say this is what the client wants. Okay, I'm not the client, sorry. But this is what he wants. He wants you to, whenever he wants you to make a stiffen end plate connection, he also wants you to cut the secondary beam like that because of whatever reason. That's not the point. So what do? I select any element of the macro, I select my node, but I also select any manually created objects. Okay? Anything which has been manually created. It could be a cut, it could be another bolt. Maybe he wants an extra bolt at the bottom, which the macro cannot do. Okay? So anything, basically, modeling. If you can model it, you can select it, right? So this is the situation. By the way, what is this case? There's a main beam, there's a secondary beam smaller than that. I've selected my joint and my macro and whatever, and I say, okay, I say clone all. It says there are 11 similar situations. Okay, so I say show unconnected ones. It shows me those situations in the model, right? So this is the one I have connected. There's the other side, obviously. Then this side, this side, this side, this side, this side, all those ones you see on the screen. 10 from these and 1 left from my own set over there. What do I do now? I just say proceed. Okay. Now what is that? What has it done? It has done exactly what I wanted it to do. I want you to appreciate the possibilities with this. You're not limited to any template. You're not limited to any style of detailing. Do whatever you want. If you're happy with that node will get multiplied. Right? And this is very different. I don't know if you're familiar with something called propagate joint. It's a command used by certain softwares. But once again, propagate joint is very similar to auto connect. It does it on a one-by-one basis. It connects one, then the other, then the other, and the other, and doesn't offer you things like manual modifications. You have to limit yourself with the macro only. And then what do you get? You get clashes. So these two technologies are actually, they sound similar, like IntelliConnect sounds similar to AutoConnect, and IntelliClone sounds similar to propagate joints. But in reality, they're much deeper. Now, I want to talk a little bit about clean drawings. I think that's important for everyone, right? Everybody wants to see some drawings, and I want to show you two examples of drawings, and I think they're important because almost everyone asks me about what about the quality of the drawings, and I want to show you the way they come out of the oven, the good, the bad, and the ugly, right? So that you know how much time you will spend cleaning them up, right? Because nothing is perfect. So I'll start with a truss example. And the reason I'm starting with the truss example is obvious. Here is a little truss. It's got a channel as the top chord, a channel as the bottom chord. Let me show the assembly. Show only. So it's a truss with a splice at the end, a splice at the bottom chord, some welded gusset connections, and I just didn't find time to connect everything. So anyway, it's a truss. It's a truss, and I'm going to create the assembly drawing of this truss. And the reason why like I said, I'm creating the assembly drawing of the truss in particular is because I know that trusses are problematic. Trusses are perhaps the most problematic in the sector. What do you do with the truss? You delete it. Yeah, you delete all the dimensions and then you start from scratch. Isn't that what we all do? Yeah, let's accept it, right? So in COMOSYS, you won't delete it, hopefully. Maybe you will add a few things, maybe you will modify a few things, but let me just, instead of talking about it, let me just select, all you do is, I'm just gonna create the drawing, say create the assembly drawing, and it creates the assembly drawing for me. It's finished. This is the assembly drawing. Let me open it. Now, this is out of the oven, directly out of the oven, as it is, okay? So I'm going to zoom in a bit. It's not bad. Now, this is what I've been told repeatedly by our users, that the quality of drawings generally in COMOSYS is better. I've been told that repeatedly, so I'm a little confident about this. And another reason why I'm confident about this is wherever I go, the number I get is something around 50-50. 50% time modeling, 50% drawing cleanup. in my own experience, in our company, the ratio is 85-15 or 90-10, right? So there is cleanup, there is always cleanup, but as you can see on the screen, it doesn't look bad. So our experience since, like I said, we've been using this since 2008, which is 16 years. So 16, it's not 6 months of experience. 16 years of experience has told us that it's somewhere around 85-15. The growing cleanup is a lot less than what we get with other software. I'm going to do one quick example. This is a multi-story building with all sorts of weird floor beams all over the place. I've got a GA setup to show you. But what I've done, can you see the general arrangement drawing? Yeah? It's a regular general arrangement drawing with lots of complicated beams going left, right, and center. But there's no dimensioning, if you notice. There are no dimensions, only the annotations have been created, right? Now, we've developed something called the automatic dimensioning of GA drawings as well. And forgive me if I make a mistake, because I tend to not use these things very often. Let me see. Yeah, so I think create the steelwork GA dimensioning. Let me limit this to 25 or maybe even 20,000. Yeah. So a few parameters. I can do the same for formwork dimensions, concrete as well, but I'm okay with this. So what do? I just select this viewport. Select the viewport. This is the viewport. It has no dimension at the moment. Just it has annotations, huh? Just annotations, no dimensions. And what needs to be dimensioned? So the grid is going like that, but all these beams need to be dimensioned, right? All these, all this little local thing over here needs to be dimensioned, right? So I'll just select this and I press this linear dimensioning of GA drawings button. That didn't work the way I wanted it to work. Let me reduce that to 15,000 and press it again. Yeah, that's better. So it's created all my dimensions, if you notice, right? And even over here, this little offsetted platform, which is not a little irregular as compared to the other one, it's found all the working points. It's gone through. There are certain parameters you can play with, but we believe that this also works with concrete, also works with steel, also works with formwork kind of situations. But basically it groups everything together, finds all the points which need to be dimensioned, groups them into subgroups. So for example, if there was something in between over here, it would find them and find those points and, you know, dimension them as well. So this is one thing I wanted to quickly go over. Now, what did I not show you? I didn't show you 95% of the stuff. I only focused on 2 or 3 of the technologies which are different. I didn't talk about auto adjust, for example. It's another revolutionary technology which will allow you to use your analysis model directly as your detailing model with maybe 10 minutes work or half an hour's work. It's going to adjust everything according to the detailed model. I didn't talk about intelligent presets of macros. Very, very interesting. Very, very useful. I didn't talk about concrete, rebar at all. None of that. One thing which I would like to show you is a few large models, because that's one thing. Let me talk about interoperability first. We do have interoperability. IFC is, like you said, the most commonly used platform these days. But we also have this bidirectional link between COMOSYS and Tekla, which will allow you to, if you have a model unmodeled in Tekla, you can just import it and continue the modeling in that will be the most common occurrence of that usage. The other way is usually, or the other requirement could be that your client wants the Tekla model, and you finish in COMOSYS, and the client doesn't have COMOSYS, so they want a Tekla model. So you can export the Tekla model as a native object, not as IFC. The only thing which doesn't go are the drawings and the numbering, right? So if you provide them if they want the model, you can give them the full model. Okay. And there's also a little trick you can do in which even if you do the numbering in Tekla, the numbers come out to be the same as the numbers in COMOSYS. That requires a little trick. So there's very nice interoperability, and there's IFC, there's analysis links to SAP 2000 and there's IFC links to Revit, there's IFC links to AutoCAD with other mechanical softwares as well. So to import your equipment, for example, right? So I think I'll stop at this point. I hope I haven't bored you. We are still together. We'll be outside. We'll be having dinner together, maybe. And we can continue talking. You can ask questions. There are 2 booths outside, which you can go there and explore a few things yourself as well. I'll be walking outside as well with you. So if you have any technical questions at this point, if you ask them from me directly, that will be better. So thank you.
Now we are opening the floor for some questions, and this is how it's going to go. If you have a burning question, just raise your hand. I'm going to go to you, and to be properly addressed, please state your name, the organization or the company that you represent. And if you're feeling a bit shy, you can also write down a note and pass it on to one of our tech prod people so that they can share it with us. Okay, we'll try to accommodate as many questions as we possibly can, as long as the time permits. Okay, so now is your chance to ask. Any takers? Don't be shy now. Or any clarifications, perhaps, or comments from the earlier presentation. So, George, tell us, what is the tipping point? Do you feel that the Philippine market is really ready for COMOSYS?
I think so. Tekla has been dominating the market for quite some time now, and none of the actual currently available detailing softwares has been able to challenge Tekla. It's not that we want to challenge Tekla, but here we have a software that is very much capable of challenging Tekla and at a much more cheaper price. So why not, right?
Yes. Why not? For sure. How about you, Atik? What are your thoughts? Do you think that the Philippine market is ready for COMOSYS?
I'll start by praising Tekla. I myself was one of the people who brought Tekla to Turkey way back in 1995. And personally, I think of so many softwares out there, Tekla is definitely very, very good, the best. But the reason why, you might ask, why we decided to even begin writing something like as complicated as COMOSYS, and this happened 25 years ago. And the reason for that is because obviously there are certain pockets like no connection to analysis, no connection to design, very little options for connection design as such. No concept of the node I just mentioned, this connectivity feature, which basically gives you this chance of attacking something like IntelliConnect or IntelliClone, right? So we were users up till all the way to 2008, but we also knew that there are areas where it can be improved upon, right? And there are still areas where Tekla is better than COMOSYS, right? So, but for many cases, for most cases, I would say, faster and cheaper solution. And these 2 words are the key. If you can produce the same thing with half the man hours at a much lower price of the software itself, why shouldn't you? That's what I wanted to say.
Faster, stronger, cheaper. All right. There you have it. Questions? Come on. Don't be shy. Now is our chance. Or perhaps you can give us a comment or 2 of what you just viewed. Ma'am, I saw you earlier. You were listening intently. Hello, good evening. Can you please share with us some of your thoughts about COMOSYS, what you've seen so far?
Well, I think yeah, you can capture it based on, well, what I can say is exactly what you said: faster, cheaper, better. So that's what we'd like to see if the promise can be delivered.
Okay. Thank you very much. There you go. But that's the elevator pitch already. I understand that we have a lot of decision makers here in the ballroom. And I also understand that there are some of the guests joining us that will take this back to their board and management committee. And in a nutshell, we've seen already what COMOSYS can do. Perhaps tell us, Atik, from around the world, your clients from different parts of the world, in general, what are their feedbacks about the software?
So generally very positive. I mean, mostly it's all positive. And the hurdles, I'll talk more about the hurdles which they face, and because that's important for everyone over here, rather than just constantly praising the software. The hurdles are the training, the initial training. That's the biggest hurdle, because when you make a decision, when you've been working with one software for 25 years, 30 years, and you make a decision to change, to migrate, it's not an easy decision. It's made easy by the prices. That's a big chunk of the decision. But even then, even with the much more attractive prices, you still think. And the reason why you think is because you know that if you migrate, you will not be able to start tomorrow. And that's true. You will not be able to start tomorrow. You will probably be able to start 2 months from now, and you'll probably be able to get to your normal speeds maybe 6 months from now, and get to whatever I am promising maybe 1 year from now. You get to what I'm saying, like it'll be double the speed, whatever. Those numbers will not come tomorrow, and that's the biggest hurdle. That's why you need people who are visionaries, who can look ahead and see that, okay, it'll be a downward curve for 2 months, but then it's going to come up, and then it's going to be much better. And not everybody can do that. A lot of people will say, no, I can't. It's too difficult a decision for me. But wherever this has happened, and it has happened a lot, wherever this has happened, the eventual results have been good. We're here to support you. We obviously want the software to be adopted. It's the new kid on the block. It's the baby which needs support of everyone. We know it's a big challenge, but we also know that what I just said was not hyperbole, was not things I was making up as a software engineer, not something I was just saying to sell something. I know that because for the last 15, 16 years, I have personally, my company has been using it, and they've used it on maybe thousands of projects. Okay, maybe 500 plus, right? And we keep statistics, as I mentioned, and we know exactly what we're talking about when we say it's double the speed or whatever. These are not just claims I'm making just because, it sounds nice when you say double. I can give you the exact number. It's 2.35. It's 2.3 times faster on average with all types of buildings, all types of modelers, bad modelers, average modelers, good modelers, difficult buildings, medium buildings, easy buildings, everything you do in 12 months. The average is 2.35. So I'm confident of that number. The only hurdle, like I said, is the initial hiccups, which you have to be willing to go through as the leader of your teams. Okay.
Like anything, there's a learning curve, but after that, you'll never look back.
Yep.
Okay, any other questions before we wrap it up? You could just raise your hand and I'll go to you. Okay, and since there are none, perhaps to nicely close this Q&A session, any final parting words? Let's begin with George.
All our colleagues who came here tonight to support this occasion, and I hope that you would be able to go back to the drawing board and decide whether or not this
program or this software is equally capable as what you are currently using? Because I think so. I think so. I've been using Tekla as well for several years, more, almost 3 decades. So, and I believe that, yeah, it can challenge the current dominant software that we are using, and it will double the production that we are currently having. So, yeah, that's what
I just want to say. I just want to add one thing to that, because I know once again from personal experience that the biggest hurdle is training. Everything else will pass. The biggest hurdle is getting your people trained. And for that, we already have more than 50 hours of formal training videos, which are available for free. And you can just log on to YouTube, go to our channels, and step by step, half an hour at a time, it'll take you through every single command in COMOSYS. All you need to do is actually watch and practice. I'll give you the other side of that as well. Very few people watch videos, even if you tell them to. They will come to a face-to-face session for training, but they will run away from watching videos. But I'm just letting you know that because this is a difficult decision, one of the major questions in your mind will be training. And it is available free of cost in a way. All you need to do is organize your people and force them into watching. Thank you.
Thank you very much. Faster, stronger, cheaper. The challenger has spoken. Thank you, Adik. Thank you, George, for answering our questions. You may now relax and enjoy the rest of the evening.
Thank you so much.
Thank you. Bring forth the belle of the night. With 6 years in finance, she excels in capital markets, financial management, and debt structuring. Appointed as SDI's head of business development and now as CEO of this new venture, Steel Drafting Innovations and Solutions Incorporated, her focus is in fostering strategic opportunities for the company's growth. This Wonder Woman / mother of two claims that plane tickets to foreign countries and concerts, passes to her favorite 90s bands are what drives her to work hard. And one important trivia about her, well, you can make this damsel not in distress with just a bowl of hot sinigang. Now we know. Ladies and gentlemen, a round of applause for Miss Jane Ponferrada.
Ladies and gentlemen, I hope everybody's having a good time. Gutom na? Di pa? O papatagalin ko to. Kidding aside, more than just introducing this innovative solution, one big reason to celebrate this moment is seeing all the stakeholders in the industry gathered together under one roof. To that alone, we are very much thankful. As we all know, our industry is growing. Hence, the need to serve it better. At sabi nga nila, faster, stronger, more reliable, and cost-efficient. We believe as players in this field, we all have the power to redefine the steel industry in our own ways and strategies. From our group, we take pride in bringing in COMOSYS to the Philippines as our contribution. We hope you can see the potential of what we have just presented, and may this moment be a redefining event to forge meaningful connections with all of you. So, on behalf of Steel Drafting Innovations and Solutions, and in honor of my hometown, Diyos mabalos sa Indugabos.
Ladies and gentlemen, welcome to the Philippine launch of COMOSYS.
Here's to embracing
changes which don't need to be complicated or expensive. Here's to us remaining open to anything that will push the boundaries of the steel detailing industry and everything that is related to it.
We keep statistics, as I mentioned, and we know exactly what we're talking about when we say it's double the speed or whatever. These are not just claims I'm making just because, you know, it sounds nice when you say double. I can give you the exact number. It's 2.35.
From our group, we take pride in bringing COMOSYS to the Philippines as our contribution. We hope you can see the potential of what we have just presented, and may this moment be a redefining event to forge meaningful connections with all of you.
Okay, good afternoon, everyone. And as promised, we have a raffle draw for all who have watched the Philippine launch of COMOSYS in the Philippines. So once more, congratulations to Steel Drafting Innovations for being the sole distributor of COMOSYS in the Philippines. So feel free to contact them at admin@steeldrafting-innovations.com or simply call or SMS them at 0917-155-1017. Okay, so the prize this afternoon is a LinkedIn Business Premium subscription. So I think this is valued at 2,000 pesos estimated monthly po. So this is for 3 months. Okay, so our first winner. So to claim your prize, simply contact me, Jomart Bakiran, in LinkedIn for you to claim your prize. Okay, so our first winner is Guillermo Valencia. Again, congratulations to Guillermo Valencia for winning a LinkedIn Business Premium subscription. So what's with the LinkedIn Business Premium subscription? Well, you can send 15 emails per month. You may see who's stalking you. You have unlimited people browsing. And for the open profile, to those people who are not your connections, they have the ability to message you. And of course, you have access to 17,000 plus LinkedIn learning courses. Okay, so for our next winner, again, congratulations to Guillermo Valencia. So please message us in LinkedIn as well. So congratulations to Blacklist. So feel free to message me in LinkedIn for you to claim your prize. And lastly, our last winner is, again, our last winner So again, if you want to know more about COMOSYS, feel free to contact our friends in Steel Drafting Innovations. Again, the number to call is 0917-155-1017. So for our last winner, congratulations to Dazzle Jane Valero Bolosan. So once more, good afternoon, everyone. And hoping to see you for our next COMOSYS learning events. Stay safe, everyone, and have a pleasant good afternoon.